welcome back to the advent of syntran. First of all, are we live? Yeah, looks like we're live. Okay. So today we're going to be adding compound assignment operators to my language. So first of all, what is compound assignment? In case you don't know, that is when you have things like x plus equals 1 as opposed to x equals x plus 1. Many programming languages have this. Fortran does not, which is kind of annoying. And maybe you're thinking, what's the big deal? Like, you just have to repeat this one letter, x, on both sides of the assignment operator. Well, it can be a big deal because the most obvious thing is that your variable name might be really long. And then you don't want to type a really long variable name on the left-hand side and the right-hand side of the assignment operator. So if you only have it once, that simplifies things a lot. So let me get away from Wikipedia. So let me just quit all of that. So let me start up a new thing. This is what we did last time, basically. I'll delete that. So let I equals 10. And then basically what we want to do is I equals I plus, let's do plus 2 instead of plus 1. And then print that. And this will work right now. At least it should, as long as I haven't made any errors, any syntax errors. And then what I'm going to do is convert this over to a compound assignment, which is not going to work. And we're going to add that to my feature, add that to my language. My language is called syntran. So let's see if this runs. There we go. It prints 12 as we expected. Start with 10, you add 2, you get 12. Now, what will not work is I plus equals 2. This is going to be syntax error. Yeah, it's saying unexpected token. It's not, the syntran interpreter is not expecting to see an equals sign right after a plus sign. So that is an unexpected token. We have a little bit of cascading errors here, which I should fix. So the first error on line number 4 is the important one. So we're going to add this to my language. But first of all, let me continue with the motivation for this feature, because you're thinking, what's the big deal? It's one letter, just write it twice on both sides of the equals sign. So the obvious case is you might have a really long variable, like if you have this, it gets pretty annoying to write that on two sides of an equation. So you would really like to convert that over to the compact syntax like this. And we basically halved the number of characters in that line of code by only putting that variable identifier on one side of the assignment operator. That's the most obvious case. The other cases are you might have an array. So might have an array, let's say it's 10 elements and it's all zeros. Let me move this around a little bit. So you might have an array, you can print that. I hope this works. Yeah, well. So that's the opposite of what I wanted. I wanted 10 zeros, not 0 tens. Forgot how my language works. Yeah, so we have 10 zeros. That's an array. What if we want to increment just one part of this array? Currently I can do this, like, let's say we want to increment the third value. arrays are indexed from 0, so the third value is at position 2. So now we've incremented this one from 0 to 1. So this is a little bit more complicated. Now we have the name of the array on both sides of the assignment operator, and we have this number 2. And it could get worse because the index of an array couldn't just be a literal. It could also be another variable. What is I? Hold on, let me reset I before I do that. Let's do 3 this time. So then instead of having a 1 here, we should end up with a 1 here. Did I write that? There we go. Yeah. So you could have a variable there, or you could have a whole expression as the subscript of an array. So we could have I plus 1. And at this point, it's very easy to introduce bugs when you don't have a compound assignment operator in your language. Because what if you want to, say, change this to I equals 2, or I plus 2 instead, and increment that value? What if you only remember to change it on the right-hand side of the equation, but you forget to change it on the left-hand side of the equation? Well, now you have a bug because you're not really incrementing the thing you want to. You're, well, it's still going to be the same thing, right? Because everything starts as 0. But if my array was a range instead, let's do a range. Let's comment out that incrementing. So you can see it's 0 through 9. This is how you do a range in syntran. So if we wanted to increment something now, let's take that back to 1. I did not write that. There we go. So now we've incremented 4 to 5. What if I want to do 2 instead? Well, this is going to be wrong, because now we have a 6 here because I did 5 plus 1 instead of 4 plus 1. So when you don't have the compound assignment operator, it gets easy to make bugs because you can have complicated expressions that have to be duplicated on both sides of the assignment operator. It could be a variable, it could be an array. The subscript itself could be a variable or even a function call. I'm not going to waste time demoing a function. So the point is, like, it's a lot more compact if we could just only put something on one side of the assignment operator, and then the language is a lot cleaner. So let's get into that. Paranoid, I just want to double check the stream. Let me go to my stream manager. Yeah. Looks like I'm streaming. Hopefully you can hear me if anybody starts watching this. I'll have all kinds of links in the description. I'll have a link to the source code. I'll have a link to my YouTube channel where, barring any technical difficulties, I will copy this stream and export it to YouTube after the fact. So let's get into it. There we go. Okay. So there are usually about 3 places where I have to make changes every time I add a feature to my language. When I add this new operator, first I'm going to have to change the lexer so that the lexer can read that token. Like, if I go back to this, it's not even expecting to find the plus equals token because that's not a letter. It's like, that letter doesn't exist in this language if you consider these 2 characters as 1 letter. So the first thing to change is the lexer to actually read these things as a token instead of like a plus token and a separate equals token. Then there's the parser, which has to analyze the grammar of these expressions. So that's the second thing that needs to change. And the third thing that needs to change is the evaluator, which goes through and actually evaluates the expressions and like adds 2 to I. So I think those are the 3 things that we're going to need to change today. So if we go to the lexer, here's my lexing function. So first it looks for digit literals, and then it does some other stuff. And eventually we get down to these operator tokens. Like there's a plus token, minus token, star token, all those things. There's an equals token and there's an equals equals token, but there's no plus equals token. This is part of all one big switch case statement, except in Fortran, instead of calling it switch case, we call it select case. So we're selecting on the current lexer character, and then we break it down, whether it's a plus sign or an equals sign. And then for 2 character tokens like equals equals, the first equals comes from this case, from the switch case, and then the second equals comes from just a little if block inside of that. So we're going to have to do something like this for plus equals. The first character is a plus, so I'm going to put it in here. You can see I already have a note to myself on like postfix and prefix operators like plus plus and minus minus. I'm planning to do that eventually, but I think today I just want to do plus equals and then like minus equals if I have time. So right now this reads 1 plus sign, and it doesn't expect anything to happen after the plus sign other than like a completely unrelated token. So we're gonna do, basically we're gonna copy this stuff down here. And you do that by getting the look ahead. So if there's a plus token followed immediately by an equals token, first of all we have to increment the lexer's position. Ooh, I don't know what I'm typing today. And then we set the token. We're going to call this, call it plus equals, or p equals. I think I want to, for the star star token, which I use for exponentiation, I have star token and then s star token. Maybe I should have named it like star star token, but I consider this a pitfall for tab completion, because if I start typing st and then tab complete, it's not going to be obvious to me whether I end up at star token or star star token. So I named it s star token, so I can type ss tab, and then it tab completes to this, and it's a little bit more predictable and easier in my opinion. So what do we want to do for plus equals? I think I already have, yeah, for the bang equals token, I have it named like bang underscore equals underscore token, so I think I'm going to name it like that for plus equals. Every token has a few things. It has the token ID, which is new. We'll have to create this. It's plus equals token. It has the position within the text. So if you have an error message, you can go back and reference the position of this token. And then it has text, which is just going to be plus equals literal. So if equals is the next character, that's what we do. And if there's something else, then we just return an equals token like we were before. Now this won't compile because I haven't declared plus equals token yet. So I need to add that to my enum of tokens. Fortran doesn't really have enums, So the way that I'm doing this is I have a big list of integer constants, and they all have different values. So if I search for equals token up at the top, you can see I have things like greater equals and less equals token, and then I also just have the regular old equals token. So I'm going to make a new token for plus equals, and this is going to be 67 because all of these integers have to be different. I don't think I need a comment. I think that's fairly obvious. So we have to add it there. I just want to search for whole words. So we have it there, and then we have to have it here in the inverse version of that table. And then there's yet another version of this table where we have, instead of like the identifier, we just have the literal characters that represent it. These are basically for error messages and diagnostics and internal debugging things. So that when I print an error message, I can either say this, or I can convert it to the actual characters that it represents, like this. So I just want to quickly scan everywhere else that I have the equals token. And I think this should at least compile now, and all of my tests should still work from everything else that I've defined. So let's try that. I hope this should pass. Well, that was surprising. It compiled. That was the first hurdle, and all of the tests passed. So that's a good sanity check. The next thing is to see if it will actually lint, or if it will actually lex this thing correctly, which this is just a new file. This is not included in any of my tests. So obviously I'm not done with the plus equals feature yet. So I haven't added this to my tests yet, but this should be a different error message than we were getting before. Yeah. Nope. Yes. So now it's lexing it as one single token. It's saying unexpected token plus equals of kind plus equals token, expected a semicolon token. This is in the parser. This is a parser error message. That means the lexer is getting everything correctly, and that works, but the parsing is where it fails because I haven't implemented that yet. So compare that to before, where it was just saying unexpected token equals. Now, if I go back to the latest run, it's saying unexpected token plus equals. So that's good. That's progress. That's a different error message. And basically the next thing is going to be the parser. So let me update the title of this stream. Yeah, there we go. I think the stream title should be updated now. Yeah, adding compound assignment. That's what I wanted to do. I still had it on yesterday's stream title. Okay, so basically everywhere that I have the equals token, I want to search for that and add a feature for the plus equals token. And then the parser also has this thing called assignment expression. This is like a type of a syntax node. So I'm going to have to search for the equals token and assignment expressions and expand those out to plus equals tokens and compound assignment expressions. I think I might not add a new expression kind. So this is an expression kind, setting it to the assignment expression. I think I'm going to keep it as an assignment expression. I'm not going to differentiate whether it's regular assignment with just equals or compound assignment with plus equals. I'm just going to call them all assignment expressions. But what I have is the operator, OP, op. So usually that's the equals token for assignment expression. I'm going to keep them all as assignment expressions and differentiate whether it's compound or regular by setting the operator to something else. And actually, I believe this is where our error message is coming from right now. It's saying it expected a semicolon or something else. It didn't expect this. Yeah, and that's because it's looking for basically an equals token and an assignment expression. So I want to search for both of these words and replace them or modify them for the new feature. So I'm going to search either equals token, and I want just the whole word. I don't want less equals token. So that's one thing. Or I want to search for assignment expression. Yeah, so now I'm finding both of those. I don't need to add a new enum. For compound assignment, I'm just going to keep them all as regular assignment expressions and differentiate by the operator. Now, here's an interesting thing. So syntran is a little bit like Rust or JavaScript or TypeScript, probably more similar to TypeScript than JavaScript, but I actually don't know TypeScript. So when you declare a variable, you use the let keyword, which is kind of like auto in C++. And then subsequently, you don't use let when you reference an existing variable. You just have it by itself. So we can do I plus equals 2, but it doesn't make sense to do let j plus equals 2, because if we're declaring j does not have an initial value. So it never makes sense to use compound assignment in a let expression. It only makes sense to use compound assignment for a variable that has already been declared. So I don't need to modify this. This is the let expression parser. So I can scroll past this and go down to the next thing, which is what we were looking at before. So this sets the operator to an equals token, and I want to modify this. I might have to take a break and not talk so much because I usually just program without constantly talking all the time, so bear with me. So we have the variable identifier. We look for any subscripts if it's an array. And then we look to see if there's an equals token. If there's an equals token, we parse this as an assignment expression. If there's not, then we rewind and read this as just an expression that doesn't have an assignment. So I want to modify this to skip if there's any kind of assignment operator. So I think I need a new function. I want a function which takes the current parser token and tells me whether it's some kind of assignment operator, whether that's regular assignment or compound assignment. So I think I want to call it is. Let me look at my other functions. First of all, where was I? Let me put a mark here, 3307. want to try to name this function consistently, so I want to take some time and think about this rather than just doing something totally off the cuff that's inconsistent with my existing naming conventions. So is binary or unary op allowed? Is none type? Okay, yeah, I think that's enough. I think I want to call it is assignment op. Is binary op allowed? Is empty. And that's not even a function, that's just a member. Is digit. Some of these are from utils, they're not defined here, they're defined in the separate translation unit. Okay, so jump back to my mark, and I want to have, it's going to be a logical function because it's going to return true or false. In Fortran, we have logical instead of Boolean. What is it going to take? I'll just use the default. So if I jump back to my mark parser current kind, I think that's just an integer. Yeah, these are just integers. So instead of using this, I'm going to call my new function. I'll just comment that out in the meantime and clean that up later. But I want to see if it's not. Right, because this checks if it's not an equals token. So I want to check if it's not an assignment operator. And then we do the early return. Otherwise, we parse some kind of assignment expression. So, yeah, so these things take integers. So this new function will also take an integer operator kind. I'm just going to copy this. It's kind of boilerplate. And we're going to modify that as needed. That's not where I wanted to go. Okay, so I'm going to take an op. By the way, I'm saying compound assignment. Apparently, the Wikipedia page is called augmented assignment. So there is different terminology that exists. I'll just make a note of that. Compound makes more sense to me. It's less syllables than augmented. So there's just an operator, there's no operand. Maybe we should keep that. No, I don't think the operator is ever going to be an unknown type. You can end up, during parsing things with syntax errors, you can end up with variables that don't have a known type. So there are things like this to prevent cascading errors. But I don't think we should ever have an operator that has, yeah, the operator is never going to be unknown. So I don't think I want to default up here. I think I want to do everything in a select case statement. No. Equals token. Or plus equals token. How do I do a default case? This is what I hate about switch case statements. Every single language has a different syntax for switch case, and it's somehow different from like the if-else syntax and everything else. Like in C++, you have to break at the end of every case, which is confusing. So I can't remember how to do a default case. I just have to look around. Yeah, there we go. Okay, default case. Then jump back to this. Yeah, I think that'll work. So because of that reason where switch case is a little bit different in every language, I used to prefer using if else all the time and totally avoiding select case. But I'm coming around because I don't have to repeat op. It's the same idea as a plus equals operator, where like with plus equals, you don't want to repeat the same variable name on both sides of the equation. If I were to refactor this as if else if instead of select case, I would have to have operator in all of my conditions. Like I would have to do it like if op equals token, then whatever else if op equals plus equals token. Then first of all, I could do it like or op equals plus equals token or whatever. And this is wrong. Do whatever in that branch, else default. The problem with if statements as opposed to select case is you repeat op in every one of these conditions. Whereas with select case, I only have op at the top, and then whatever I'm comparing it to on the right side goes in right side of the condition goes into these cases, but I'm not repeating op. It's the same idea as plus equals. It's a little bit more compact. So I guess that makes the weird syntax worth it. And then in languages like Rust, you have more advanced pattern matching for switch cases. So I'm coming around. So I think this is basically our function for now. Eventually, I'm going to come back and add like a minus equals token, but I don't have that yet. I just want to get plus equals working to begin with, and then we'll come back and do those other things. So I think this should compile, and I think my tests should still pass. And then what was I searching for before? I want to search for this thing to modify the rest of the stuff. So we're still going to end up with an error message at this point for this new code, but I think the test should still run and pass. Nope. That should be fairly easy to fix. There we go. All right, now the next thing is I don't want to match just an equals token. I think I shouldn't have to match here. This is a case where I should have more bad syntax tests. Trying to think of what I want to do here. How do I consume a token? not set. Isn't this like the one mark that I set? How did I wipe it out? Anyway, set a new mark. There we go. Parser next. I think parser next is what I want. So let me jump back to this. I had this aligned before, so let's keep it aligned. What match does? Is it function? Yeah, what match does is it checks if the current parser token matches what you expect. If so, it just returns it. Otherwise, it pushes a diagnostic to the list of error messages. And that's how we end up with things like unexpected token. Or okay, sorry, this is actually a Fortran error message. So yeah, that's what match does. Basically, match does error handling. But I don't really want to say I'm expecting an equals token because I'm not necessarily expecting an equals token now. It could be an equals token or it could be a plus equals token. So I don't want to match it. I'm basically already checking whether it is that type of token or not right here. So I think I don't want to match. I don't want to do any error handling. I just want to get the next token and say that's the operator. And I think that should be okay. And the tests should still pass. Yeah. What does this do? Okay. Wow, I think the parsing might be done. That was easy. So if you remembered before, we were getting, this is a Fortran error. Here's the syntran error. It was saying unexpected token plus equals. Now we are getting binary operator is not defined. No, it's still, I think it's still a parser error. This is not, is this an evaluator error? What happens with the operator here? Yeah, so I think this is what's happening. Basically, the operator is not allowed because the type checker, like let's say I was a float and 2 is an integer, then you wouldn't be allowed to increment a float by an integer. So there has to be type checking in here. And right now, basically, this new operator, which we've just added, it's not defined for any types. So there's always this error message. I just want to confirm that this is actually where the error message is. Yeah, it's a bad type right there. So we need to go in and modify is binary op allowed. I don't know why I searched like that. I learned a new Vim feature the other day where if you have your cursor somewhere, you can just type star or asterisk and it will search for whatever word is under your cursor. So that's what I should have done right there, but I didn't. I need to get that into my memory so that I use it instead of wasting time typing for something that's right next to my cursor. So basically we need to go ahead and define the types that are allowed for plus equals. and it's going to be the same as plus. So whatever operands you can add with a plus operation, you can modify that thing with a plus equals. Why is plus different than, oh, because plus also works with strings. So one thing that I can do in syntran is I can have strings. Like I can say hello as one string, and then I can have another string that says world, and then you can do string 1 plus string 2. That's how you concatenate strings. Actually, in here, you can either use the variadic version of println, which is separating arguments with commas, or if everything is a string to begin with, you can just concatenate them and only give one argument to println. So, like, see, now I have my two separate strings combined into a single string, and actually it concatenates again with this str_sum prefix. So yeah, the point is the plus operator is defined for numeric types, whether integer or floating point, and it's also defined for strings. So that's why the plus token has different logic than the minus token. Yeah, I think that's all I wanted to demo right there. And then go back to this thing. Yeah, okay. So that's why the plus token has special logic, which is different from the minus token, because the minus token only works with numeric types. You can't subtract strings. Maybe you could have a language where you say, I want to remove a substring from some other string, and you use the minus token for that. I don't know if anything does that. It's kind of weird. I don't think I want to do that. So the plus token works with strings, minus token does not. And yeah, you should be able to do plus equals on a string as well. So I just want to add a note to myself here. So now my operator should be allowed. It was saying binary operator is not allowed. If I recompile and rerun, I don't know what's going to happen. What? Okay. So yeah, it runs. It's incorrect. So the type checker passes, but I haven't done anything to differentiate compound assignment from regular assignment. So this is all getting lexed and parsed correctly, but instead of actually adding to I, it's just doing regular assignment. So it's saying I equals 2, and I end up with I equals 2 there. It totally ignores the fact that I have a plus equals token there, not an equals token. So that's why I get 2. But what we're expecting is 12, because we have to take the initial value of I and add 2 to it. So that's going to be the next thing, and that happens in the evaluator. So I think we're almost done here. I think the parser is basically complete. And now we go to this monster function called syntax eval, which is right here. It takes an abstract syntax node, and it also takes all of the variables that are defined so far within the scope, and all of the functions that have been declared or defined, and some other context, like whether you want to log certain things to the console or not. So this function is what evaluates a syntax node. So I need to go in here and modify the assignment expression. And where was that regular expression that I was searching for? Here it is. So this is the assignment expression case. And this is within the syntax eval function. So we have a branch here for scalars, and then we have another branch for arrays with subscripts. Yeah. So first I just want to handle scalars. Like I is a scalar here, it's not an array. That's what I want to get done for now. I might do arrays off stream. We'll see. I don't know what I want to do at the end of this stream. I might go and do minus equals, or maybe I'll do arrays if I'm feeling good. So, yeah, here it is. We take the left-hand side and we assign it to the right-hand side. That's how regular assignment works. The right-hand side itself comes from another syntax evaluation. So this function, remember, we are within this function syntax eval. It is, let me page up. This is a really long function. It's recursive. It has to call itself because when we're evaluating one syntax node, whatever's on the left-hand side equation, it's going to depend on whatever's on the right-hand side of the equation. So syntax eval has to call itself to evaluate the right-hand side. This is just node, right? In Fortran, you use a percent operator to access members of a struct. So in C, like it would be node dot right, or if it's a pointer, node arrow right. In Fortran, you use percent instead for that. So this evaluates the right-hand side, and then that goes into this temporary variable res, and then res gets assigned to the left-hand side, which is something from the variable dictionary. So we access the variables by their identifier. Like it's I. We have to look that up in some dictionary. That's handled by vars. So that's how that works for regular assignment. Now, what I need to do in here is I need to put a select case which looks at the operator. First of all, I want to see what the operator is. So I'm going to put a little printing in here. This is scalar. This is the whole point of compound assignment. Like I was saying at the beginning of the stream, like you could have a really long variable name. That's kind of stupid because you can just use tab completion. The real advantage of compound assignment is when you're using it on arrays and you don't want to repeat the subscript expression on both sides of the assignment operator. So I'm doing scalars first, but the real beauty of compound assignment comes through for arrays, and that's in this other branch, so I'll have to do that later. And the operator, I think it should just be node %op. That's the way I have my abstract syntax node structure set up. So I hope that compiles. Node. What the hell is node? Node op. What the hell is the op? The op is a token. So this is my syntax node type. In Fortran, instead of structs, we have types or user-defined types. So this is my syntax node struct. And then the operator of a syntax node, like you have left hand, you have, for binary expressions, you have something on the left, then you have an operator, then you have something on the right. Excuse the mirror imaging. So the syntax node can have all kinds of different things for different types of expressions, whether it's a binary expression or a unary expression or an assignment expression or a function call or whatever. Uh, so it can have a child operator, and the operator is also not a primitive type, it's a syntax token type. Uh, so what I'm interested in is the kind of the operator, because if I look at, let me do this fancy star search. If I search for syntax token type, it's right up here. Basically, it has a kind, which defines that enum that I showed you at the top. So the kind of the syntax token is going to be something from this list of enums. So I'm going to be interested in whether it's a plus equals or a regular assignment. Anyway, so I don't just want to print this because this is a struct. You can't just print a struct because like there's no default formatter for it. I have helper functions that convert this to, so it says 67. That's the new one that we just defined for plus equals. That's good. That makes sense. And I think convert this to strings somehow. How do I do that? Text, node op text. So this should now say plus equals instead of 67, which like, what the hell is 67? I only know it's 67 because I just programmed it on this stream. There we go, plus equals. That's a little bit more readable for debugging. So now we can go ahead and do the logic. Might need a coffee refill soon. So if I don't think I want to do if, I think I want to select case. Let's see if I can remember how to do this. Node op kind. And then for equals token, we're going to do that. And then we're going to have a case for plus equals. And then we're going to have a default case, which should just be some kind of error message if it's not explicitly handled. It should already be handled by the parser. So, come on, man. So this default case should already be caught by the parser. But just in case I haven't caught that, I'm going to leave this extra error handling in here. And this is just an internal compiler error, or really it's an interpreter, not a compiler. So this is an internal interpreter error, and then it just stops execution because whatever you get after this point is going to be garbage. I'm not going to fill in that to-do just yet. I want to check that my tests should still pass. That's a lot of printing. Yeah, everything still passed. Is that all I did? Yeah. And then that's not quite done yet. Okay, now remember we were having 2 here before? Now it's 10. Now it's just not doing anything because we have a do nothing operation here. So I think we're almost done. Now Fortran does not have compound assignment. That's one of my biggest gripes about Fortran. It doesn't have compound assignment. What else doesn't it have that annoys me? I can't remember. But it doesn't have this feature, so within the Fortran interpreter, we have to do this expanded stuff. I can't actually use plus equals within Fortran because it doesn't exist. But I'm using Fortran to interpret my own language, and my own language, which is bootstrapped on top of Fortran, it has a plus equals operator. So that's pretty cool. That's how computers work. What's wrong with that? Yeah. So within this, I need to have types because res is a value. It's an abstract value. If I go back up to the subroutine, or function, it's res is a value. This is abstract. A value type can be, it can be a string, it can be a bool, it can be an integer, it can be a float, it can be an array. So this is abstract. A value can be any kind of type. It's kind of like an unlimited polymorphic object in C#, I guess. So when we do plus equals, I can't just add these because this isn't a number. It's an object. So if I look at how the plus token is defined, this is unary. I want to look for the binary one. If we look at how the plus token is defined, it checks the types of the left operand and the right operand, and then it either adds the integers or it adds the floats, or if you have a float on the left and an integer on the right, it will mix and match those. That's fine. That's not an error like in Rust. So basically, we need something like this for plus equals, and is there some way that I can refactor this so that I can not have to copy and paste it? I'll have to think about that, but for right now, I'm just going to copy paste it. So quickly, I think I need a coffee refill. How do I pause the stream? Actually don't know how to pause. Can I pause from within Twitch? I can pause viewing first. Underneath, I have this always on top window so that I know where my webcam is, like soding. Yeah, I guess I'll just keep the stream going, but I will be right back. I just need a coffee refill. Okay, I'm back. So, oh god. And I just remembered how terrible this is. So, yeah, I really need to refactor this as a function. Sorry, my heat was just turned on, so everything's cracking and popping. So instead of left and right, I want like vars, vals. Let me simplify this. Let me just assume that I'm working with integers to begin with. So if we're working with integers, it's going to be, instead of the whole result value, it's just going to be the I32 child of that. Now you can see why I really want the plus equals operator in Fortran, because I don't want to have to repeat this nonsense on both sides of the assignment operator. This line is too long. So if I assume I'm working with integers, I think it should work like that. That's it. I is 12. So we started with I equals 10, and then we said I plus equals 2, and now I is 12. That's basically it. This code is messy. So I think I want to go and refactor that addition as a function. Because like this is the block that I use in the binary expression evaluator. First of all, it does this magical thing where I have this constant called 128. In Fortran, you cannot select for a vector of cases, if that makes sense, right? Like you cannot do select case, left type, right type. Like if this were an array. What I would like to be able to do in Fortran is I32 type, I32 type, this is what I would like to be able to do, where I'm selecting for the left type and the right type simultaneously. But you can't do that. You can only have scalar expressions in select case statements. Like, I think I could try to compile this and show you the actual error message. Yeah, argument of select statement must be a scalar expression. So you can try to put an array there, but Fortran will complain. So you can't do this, but what I can do is I can convert my vector to a scalar. As long as I add some magic number that's bigger than the largest possible value of the left type and the right type. Like, let's say left type was anything from 0 to 9 and right type was anything from 0 to 9. Then if I multiply this by 10 and add the right type, then I get a unique number somewhere from 0 to 100 or 0 to 99. And then I can select by a scalar instead of a vector. So we're emulating vector or array select case by converting our vector to a scalar manually. So then this will actually compile, right? That's insane. So I'm using this magic number, which is 128, and 128, it just has to be bigger than my biggest possible enum. I might have to raise it to like 256 at some point if I had a lot more token types, but that kind of works for now. So instead of doing this and modifying like left type as this big nasty expression, I think I want to refactor this as a function right now, but I think I'm ready to commit because this works, right? Like, this works for integers, and I think all my tests should still pass. Yeah, so I'm ready to commit right now. Even though I know this doesn't work for floats or strings or like a mixture of floats and ints, it works for all of my tests, and it works for this new example which I've written. So I think I'm ready to commit this right now. I'd just like to review my status before I commit. Don't need this line anymore, so I'm going to get rid of that. About the match. Like, this if condition already handles the case where it's not some kind of assignment operator, and then it parses a primary expression basically and returns early. So I really don't need to do any error handling here. I think I can just get rid of that. Function, I think this function is okay. Okay, I think I'm ready to commit. So that's the minimum viable product. I think that's ready. Come on. So we have this. Looks like all my code is there. I have automated testing that runs the same testing, unit testing, integration testing that I run locally. That also runs on GitHub as an action. So that should pass. Windows actually doesn't run the tests. That checkmark was there and then it just disappeared. Yeah, there it is. There we go. Okay. Oh, I'm not logged in. Oh, why does everything have two-factor authentication? Like, this is my personal GitHub. Like, I really don't care. I'd rather... Okay. Fine. Yeah, so these are running on GitHub. Standard output is a little bit clobbered, but yeah, everything passed, nothing failed. That's a good sanity check. So now I want to try to do this as a function so that I don't actually need to copy and paste all this. So I think I want to do that with the binary expression evaluator first. So the funny thing is, for the binary expression, I set the type of the result here, whether it's integer or float or whatever, and then I set the value down here. So if I refactor this, it can't be a function because the function would also need to set the type, but I want to have that handled separately. Because for the compound assignment, we already have the type assigned. So I want to put this inside a routine, but I don't want to put this inside a routine. Yeah, because it's different whether it's a binary expression or a compound assignment expression. So I think I want to call this as a subroutine, not a function, and just pass everything by reference. Fortran passes everything by reference anyway. It doesn't have pass by value like C. So I want to call add. I just want to call it add. Maybe add values for now, because like left and right, these are all values. Like these are all value types here. So I'm just putting this in the name of the routine for now. Eventually I can do something like this inside value. I can have a procedure. Maybe I'll just do it right now. Add is going to point to add value. And then we're going to have different functions for adding and subtracting and multiplying and all that jazz. So for now, is this a procedure? maybe I want an interface instead of a procedure. So I'm gonna forget about that for now. Yank that. Oh. No, I don't want it there. I want it. See, the binary expression, it handles adding and subtracting, so I want it inside of this case. So maybe I'll like unify these as one big function later, which handles any type of operator. But for now, I just want to do addition. So it's going to be like that. And then I want to yank this. Comment that out. Syntax eval my whole function. The whole rest of this file. Yeah, so it ends right there. Paste it there. I don't know what I just did. Okay. So this is a subroutine. Can get rid of a couple indentation levels. So I don't want this to be a class. I just want it to be a type. And the first two are going to be intent in. And that's going to be intent out. So everything is named consistently. I'm ready to give that a shot. Let's see what that does. Let me just run my tests. Magic is not defined. Is that not like a global? That's in here. What am I going to do with that? I should probably name it something other than magic. Uh, 5913. Do I want to pass the node to this function? I guess I'd better. Trying to think if I can like just pass the text or What's the best way to refactor this? Because this is add, so I could hard code this as just like plus string. Okay, I failed to write. I think I could do that, but I hate it. That doesn't even work. Left, right, res. First of all. Left, right, res. What happened there? Why didn't that work? What is... Left, right, and res are all values, right? Left, yeah, left and right are values. Res is a value. The type is already set. So this is not intent out, this is intent in out, because the type gets passed into the into the subroutine, and it has to remain. When you have intent out, basically it wipes out, Fortran wipes out anything that you have in this out arg. So I need this to be type intent in out. Let's go. All right, so that function works, and I think I can probably use this function for compound addition now. So I'm not copying and pasting. Now, instead of those arguments, I want come on. Come on. That's what I wanted. I need to add some kind of Vim key binding for commenting and uncommenting things, because what I do is I do block insert, and then I just insert, you know, whatever characters I want, which is just the bang. Bang is a comment in Fortran, if you couldn't tell by context. So I need a key binding to automate that. So the left is this thing. No, the left is the result. Yeah. No. Res is the right-hand side. So yeah, this is correct. And then the variable is the left-hand side. So left, right, and then the result is also this. That's what makes it compound assignment. Hopefully I have all my parentheses matched there. My cat is going nuts. Callie. Let me check on my cat real quick. All right, I think my cat just wanted attention more than any type of critical need. So here she is. Here's Callie. She doesn't really like being picked up all that much, so I'm gonna put her down. Callie is very incensed that I don't have a cat function intrinsically in syntran. Uh, my concatenation for strings is just the plus operator, or there's also the string function, which converts things to strings, and it's variadic, so it also concatenates. So she's very incensed that I don't have an actual intrinsic function named cat in syntran. Okay, so I see what I did here. We can get rid of the I32s here because we want to pass the whole value. Let me bump this up to this line. Is that going to work? Nope. Oh, 5348. I think I just forgot to write this. There we go. And can I run this thing? So it's still 12? Cool. Let me change that to like a 3. Very cool. And this should work for floats now. So let f equals, what's a good float? 3.14. Yeah, that's fine. F plus equals 2.718. I forgot a semicolon. Hey, I'm not going to check my math there, but that seems about right. Pi plus e. Will this work for strings? I would be a little bit surprised if this works for strings. I can get rid of this to-do note because I just did that. Like, there's no way this is going to work for strings. Wow. Hey, that's not bad. I think I'm gonna commit again. I've been streaming for a while and my cat wants attention, so I think I'm gonna try to write a couple quick test cases. I might not be able to test all of these things thoroughly, but I want like at least one test right now on stream so that you can see how that works. And then Callie wants some kind of attention, so I'm gonna have to cut it off soon. Status diff. I have a bunch of stuff commented out somewhere. I can get rid of that. Yeah, I have this add value function now. I need to do other functions for subtracting and multiplying and exponentiation and division and modulo, and probably logical operators too. So for now, like I only have these in one place, so there's no point in refactoring them yet. But once I add compound assignment for all of those operators, then it will make sense to have a value or a a subroutine to do that so that I don't have to copy paste everywhere. So first of all, I deleted some stuff. I want to make sure I didn't mess anything up. Tests still pass, that still works. And my diff should be a little bit cleaner now. Now I just want to write a quick test or a couple quick tests. I think this is utils. This is not my test. So what do I have open? I have basic tests in here, which are usually one-liners. Like there's a bunch of arithmetic tests. Where do I actually test? I have floating point tests, but not assignment. Does this count as assignment? I might want to have a different top-level testing routine just for compound assignment, but for now, I think I'm going to lump it in with assignment. Like you can see some of these are one-liners where I have one line of syntran code and then that gets evaluated within Fortran as the test and compared to the expected result. For anything, and then I also have like multi-liners. For anything that's more than like a couple lines of code, I don't like to hard code it within Fortran. I like to have a separate syntran source file and then test that separately. But for now, I think I can have like a simple two-line test. And I'm going to put it right here. I'm not going to put it as the last one because, you know, everything except the last one has to have a comma separator, and then the last one does not have a comma after it, so I like to put it right before the last one. And I'm just basically going to test what I just did in the other window. Let's call it J instead of I. Let J equal 10. J plus equals 3. And then that should evaluate to 13. So whenever I have a multi-line test, the return value of the evaluated string is whatever the last statement of the test is. So these are all one line, technically, but I have statements separated by semicolons. So whatever the last statement is, in this case this one, that's the return value of the evaluation. So that should be 13. So I expect that to be 13. For the testing, I'm doing stringly typing. It actually returns an integer, but for testing purposes, I compare it by strings. You can see in other places I have eval I32. Like this actually compares to an integer result. But for just doing things general purpose, this way I don't really have to care about the type. I just can call eval without having to worry about what type it is. So that should, I think that should work. What did I have before? Like 374 tests. So this should take me up to 375. And it failed. I think I need one more line. Okay, so what happens here is, yeah, when I just had it like this doesn't return J. It returns the result of the right-hand side, which is actually just 3. So it does add to J, but that's not what it returns. So if I want to return J and use that as the test result, then I have to have one more statement, which is just J, and now it's 13. I mean, J was 13 before, but that wasn't the return value of the evaluation. Yeah, so that works. Now I'm up to 375 tests. We can verify that I can break this if I put some unexpected result. So now there's a test failure. Put it back to 13. Let's also test floats. This is tricky because you have to be careful with floating point arithmetic. Really, I should use a tolerance, but c'est la vie. Let's do a half and add a quarter, and then it's not J, it's F. Huh. La vie, say. Thanks, Unicorn. Thanks for tuning in, guys. I did not expect anybody to actually watch this, so thanks for tuning in. So F starts as a 5, and it should end up as 3/4. So this should be 376 tests. Nope, I did something wrong. Yeah, the return value. So, right, I'm doing stringly typing, so it's not actually 0.75, it's exponential notation. If I can remember how to paste in NeoVim. There we go. So if I test that, nope, it's still not right. Did I forget to write it? Yeah, what is going on? Is this the one that's failing? That's the one that's failing. You can see it was printing too. Like I forgot to make the test quiet because I like my unit tests to not actually output anything. So if something fails, I can see it. You can see, oh, I have to trim it. Yeah, I have leading white space here. So you can see some of my other tests. Where? Do I not trim the test results? How do I test floats? So here's a test with a tolerance comparison. That's the way I should do this. So I do use tolerances everywhere. Yeah, I guess that's what I should do. 7.5, where was this? Okay, so this is a numerical floating point issue, I guess. My cat wants attention, so I have to end the stream soon. Minus 0.75. That should be less than some tolerance. I need to define a tolerance within this routine. And will that work? All right, there we go. 376 tests passed. I want to do a string since I know that that works. Let s equals hello, s plus equals world, and then compare that. It should be hello world. I might need an extra set of quotes in here. I think it trims the quotes from around the string when it returns. So this might work. Yeah, that's 377. I'm gonna have to clean this up so that it's not dumping that output into my unit test output, but I think I'm gonna end the stream here. Just commit quickly. My cat desperately wants some attention, so I'll give that to her. I'm gonna add more tests later, at least that's the plan. So those are just some tests for now. Let me make sure that that pushed. So we have some tests now. Everything before that was passing, so that's good. All right, well, thanks for tuning in. Hopefully I can do this again maybe next weekend. So that's all for now. I'll see you guys later.